Hola, gracias. So I have no clue what has been said about me, but I think it's mostly correct. So welcome to my little presentation. Actually, I submitted this as a turbo talk, so it's going to be quick and rough, and I'll try to bring the three topics of GitHub, Ruby on Rails, and Argentina under one talk. So let's jump into my introduction slide. Who am I? My name is Joernchen. I'm working at Security Labs in Germany, in Berlin, since almost 10 years now as your usual security consultant, where I do code audits, pen testing, design reviews, hacking, whatever comes up to my desk. In my spare time, I developed a certain fetish for Ruby on Rails applications. So I spend huge chunks of my free time looking at Rails applications and the framework itself, and as I said, of course, some fallout in terms of bugs. And about one specific thing I'll talk here today. It's nothing brand new, but I hope to get a bigger picture, which is at least interesting for you here in Argentina, or anywhere else, I hope. And well, in the other part of my free time, I try to party a lot, and I'm DJing, so party hard. Tomorrow night, I'll be spinning for you guys at this venue after the talks. So I hope to see you there, and you move your asses. Okay, let's jump right into the technical stuff. Ruby on Rails is a web application framework, model view controller, blah, blah, blah. Every serious web application framework should have some kind of session handling, where in PHP you usually have a session ID, which refers to some memory or database entry of the according session data. In Rails, by default, it's a bit different. All session data is held client-side within the browser in a cookie. This is actually quite useful in some scenarios where you have multiple front ends and don't want to have a shared backend for the session storage, because everything you need from the session is in the browser of the user, and he or she sends it out with every request to the server. Typically, it looks like this. We have a underscore my Rails app name underscore session, and then for the this is like the old version of the Ruby on Rails session. They changed some stuff in there. You have a base64 blob, dash dash, and HMAC of that base64 blob. So within this base64, if you decode it, you either get JSON or Marshall serialized data, which then would be deserialized within the framework. And the session object is available to the Rails framework. For JSON, it should be clear, because JSON is a very widely deployed data format. But Marshall is something which is Ruby-specific type of serialization. I'll come to that in a minute. So wait a minute, sorry. For the older Ruby versions, you have Marshall, so Ruby internal serialization format cookies, and for the newer Ruby on Rails versions, you would have JSON. To sign it, or for the newer versions to also encrypt the session cookie, you would need a secret. Well, and this is like the root cause of why I'm here. You can, if you know the secret to HMAC, you can forge Ruby sessions, or if you find the HMAC to a specific Ruby application, the HMAC secret, you can then control that application, and you can say, hey, this is my session object, and my user ID is not 13 but 1, so I'm the admin. Please let me in, and it would just work if you sign it correctly. The session secret is, or used to be, generated upon application creation, and the location might differ from version to version. So usually it's under app name, config, initializers, and then session store or secret token.rb. Or in the most recent versions, it's just stored in the environment variables to get rid of people losing those secrets in a large scale. So if you have the secret, you can, up to version 4.0 of Ruby on Rails, you can have RCE, because the Marshall format yields RCE if you deserialize the right or wrong objects. For versions up from 4.1, it depends, because there's still a fallback to the Marshall serializer in certain corner cases, and that could work too. So, well, it depends. At least you can forge sessions, but up to 4.0, you have definite remote code execution. To have a look at this Marshall format a bit. So this is a Ruby shell, and we take an object foo, assign it to an array which contains a funky string and a lead hash, and then we Marshall dump, which is the process of serializing it, and we'll just get a string with a magic number, and somewhere in here it's a kind of a type length value scheme. We have a funky string, and somewhere we have a hash with this number in here. And if you Marshall.load that object, you would get the very same array back. This is like just the basic. I'm going to explain a few more building blocks within this talk. So this object, this is directly taken from a Metasploit module I wrote to exploit this issue. The object itself, well, the technique to use this combination of objects was not my idea. There was some guy called Charla who, funny enough, works at GitHub, who came up with this exploit. And we'll see here we have something in here, active support deprecation, deprecated instance variable proxy, where I think deprecated instance variable proxy is a very nice word, because it sounds so German, because it's so long and multiple words stick together, because we Germans like to do that. We have an instance and a source. Here's where our payload will be. I'll explain the whole thing in a minute. And we got a method result. So this will hopefully make sense after the next couple of slides to you. So this is the marshaled object we need to create in order to let the Ruby on Rails application run our code. Good. So some specialities in Ruby. There's lots of magic in Ruby, and some might be dangerous, as magic tends to be. For instance, method missing. Method missing is a thing or a method which will be called if the method you're calling on the object is not defined, but method missing is defined, then method missing will be called instead. Does it make sense? I hope so. So whenever we got an example. We have a class foo, we define a method missing with one argument, which is the name of the method we're trying to call, and it would just say, you called name which does not exist. And then we create a new object, and then we say .who, which would be the method on that object, but it doesn't exist, so it would just say, you called who, which doesn't exist. So much for method missing. So it's actually a placeholder catch-all method within Ruby. The other thing we need in order to understand this exploit is send, where send is a kind of an indirection. It lets you call methods by their name. That you give it a string or a symbol, where a symbol basically is something like a string in Ruby is minor difference for now. So you can invoke the method by its name, which would be here the symbol, and attach as many arguments as you want to send, and send would just send it. And then that method would be executed on the object where you call send upon. So this is built into the Ruby object class, so it's available in every object. So to understand this deprecated instance variable proxy a bit more, we have here the class definition. It inherits from the deprecation proxy. We got a constructor. You can see what types of instance variables are defined. That doesn't matter too much, but we see we got the instant method, var, a deprecator, but the important part is here the instance and the method. Well, as well, there is a private method defined, which is called target, and here we have the set method send, which would send the method to the instance, which both are variables within this instance variables within this instance of the deprecated instance variable proxy. This word is really terrible. And the parent class, the deprecation proxy, would have defined a method missing, which would use the target method we just saw, and from here it would send some stuff to the target method, but it doesn't matter for us because if we remember within target we sent a defined object, a defined variable to a defined instance variable. So for the deserialization, it's now important if you deserialize an object via Marshall, it would be not calling the constructor, but it would be directly allocated. And so in order to do so, in order to have the object in place afterwards, it would just allocate the object and fill out all the variables which are defined within the marshaled string. So we can then have something like this. And can you read this in the back, or we'll have the thank you, the proxy, a deprecated instance variable proxy. It contains a method and an instance. The instance is an ERB object, which is the Ruby templating, kind of a HTML template language within Ruby on Rails. And this ERB object contains a source. The source is whatever Ruby code we decide, we can put it in there. And then for the method we have result. Whenever you call result on an ERB object, it would take the source, whatever is defined as source within this object, and execute it. So as we get a free call to method with an instance, we get a free call to result within our ERB object, which contains the source of our choice. And this is how this exploit works. So the only thing you need would be the secret. And that's not a big issue, or it didn't used to be a big issue, because funny enough, people learn when they get their first crash course in Ruby on Rails, okay, we code now a little web blog, something kind of thing. It's all super easy and takes us just 1 hour to finish it. And then we put it in GitHub so everybody can see we're a good developer and writing super awesome Rails apps. And no one noticed that, or a few people just noticed they put their application secret within there. So news at 11, people put stuff on GitHub which shouldn't be there. So do Ruby on Rails developers. There's also, by a friend of mine called Mike Henriksen, a nice tool to automate the search of interesting files within GitHub, which is called GitRob. So back in the days, that was like 2011, 2012, I started scraping GitHub, and the search engine sucked back then. I think it still sucks. Scraping GitHub for Ruby on Rails secrets, and I found a lot of stuff that was almost 5,000 unique tokens. Mostly it was pretty uninteresting, like really my first Rails app, empty demo app, or just boring. But there were some gems within there, and one of those will now make sense in a minute in the Argentinian context. Also, I would like to thank a guy called Wick who did the Git Digger project, which was he downloaded every single public repo on GitHub and had a big database of all Git repositories out there. And when I saw this, I mailed him he was, yeah, if you need all the Ruby-related stuff, I can just grab it for you and send it to you. So that made my database, a little big data database, even a bit bigger. So I don't know if anyone here is in the ISP context, like Internet Service Provider. There is a ISP management panel. By now it's called Vispro. And Vispro is developed in Buenos Aires. And Vispro is based on a Ruby on Rails application, which back then, when I was grabbing all the tokens from GitHub, was called Secure ISP. And they had this exact very problem. So what you see here is from the website of the product, how it's now. That's like, it says something like 3,000 installations and 2 million internet users connected via our product. So basically, with this secret token of that Ruby on Rails application, you could have owned like 2 million people's internet lines. And most of them are in Argentina. So yeah, ISP management panel widely deployed here. Also, yeah, it has an open source branch, which then turned into the closed source version, Vispro, and it's designed for small and medium-sized ISPs. So it could have been fun. It has lots of features which you get for free if you just create. You don't even have to do RCE. You just could create a token which authenticates you as administrator and download the traffic logs of your neighbor, maybe, if he's connected via such a line. So a lot of stuff would have been possible with that bug. I disclosed this earlier this year in the process of putting this stuff into the Ekoparty CFP. So I didn't want to go to jail in Argentina, so I disclosed before. And in terms of deployments, I had a look at Shodan. If you see, this is the name of the session cookie. And we have, oh, I can read it here better. We have like almost 3,000 hosts with that session cookie within Argentina and then some more in South America. And yeah, this was actually fun stuff. This was one of the gems out of my big bag of Ruby secrets. Well, and beyond this, what really, I mean, you could just yell at the cloud because everybody thinks they need to put their shit in the cloud. You must publish every meaningful or non-meaningful piece of code on GitHub, or you just, I don't know, it's like a combination of fails. I mean, Rails failed to put the secret out of the source tree. People failed to realize this, and so this came. I just wanted to show this picture. We should all yell more at cloud. That's my conclusion. Thank you. Are there any questions? What's the exact token like? It's like a very long string, hexadecimal string. So the question was what the exact token is. It's a very long like hex string. You can look it up on GitHub. You go to github.com/secure-isp/secure-isp to the project repo. You go to config initializers secret token.rb. It's still there, but in their production setup they fixed it. Okay.
¿Alguna pregunta más?
A question about Ruby, which I don't know much about. Is it possible to demarshal to any object, or are there any restrictions on that?
It's not possible to marshal any object. So there are certain objects which you cannot serialize. But I think it's possible to just say, hey, I serialize this object, and then trying to load it. Yes. This is possible. I had crashes with such instances.
¿Alguna pregunta más? Bueno, muchísimas gracias, Joernchen.
Gracias.